Uh, hello, you all. I'm I'm Raphaël, a software engineer at Criteo.
Speak as loud as you can, Raphaël.
Okay, I'll do that. So I've joined Criteo 8 months ago in the Paris office in a team called DRE Storage. DRE standing for Data Reliability Engineer. It's kind of inspired by SRE, and it's kind of applying the same principle to data. So by principle I mean trying to automate reliably any manual operation that you would need to do, so that software deals with all the operational part as much as it can. In this presentation, I start parroting my engineering lead who could not make it today to tell you about the story of the field story of analytic platform at Criteo, how it evolved over time, and the recent work we've done, and what we kind of see for the future. So without further ado, in the early days, you will recall like some of the stuff we heard in earlier presentation during this one. So it was about SQL servers at Criteo. Data was sharded by clients on multiple instances. It worked quite well for transactional usage, but to consolidate data, you had to use several servers. Consolidating data was hard. In practice, the data analysts that used the platform had three options at that time. The first was to use all the servers from all around the world and a reference table to do cross-join, and this was like painful and hard. Another one they could do is use a big StatDB where they gathered like all the most relevant data for consolidation. But at some point, with the growth of Criteo business, this database ended up being too fat and unqueryable. Same fate happened to a NoLab cube. So in the same period, we started a small cluster, Hadoop cluster, with a few raw data sources in it. Since the analysts know SQL well, and very well even, we figure out as an infrastructure team we will just install the Hive metastore on a MySQL server, set up all the configuration needed and a Hive client on a server that analysts could SSH to, and this way analysts had Hive. So for the first time they were able to create all Criteo data at once with MapReduce. But it was slow. It wasn't very interactive. So why is that? Well, the data was in JSON and compressed with gzip. So, and Hadoop is no magic. We heard this morning about Parquet, and like you can do better than JSON. So in 2013, along with some Twitter folks, Criteo's contributed to Hive Parquet integration to move our data sets into Parquet, but still, MapReduce on Parquet is not fast enough for a dynamic interactive analytics. So we needed something else. So this is gathered a bunch of contestants in 2013. So they needed something with an order of second response time. that was able to store almost actionable data sets. At that time, it grew since it meant dozens of terabytes. So they already knew SQL wouldn't fit the bill. That could properly execute the SQL ANSI, and that did not rely on proprietary appliance. So Vertica was selected out of this process. So in one slide, we've heard from Julien Ledem this morning all the good properties that columnar storage on disk and in memory has. So Vertica is around that. It's a scale-out MPP with a no single point of failure architecture, so it's reliable, and you can add nodes to store up to petabytes of data. It supports the full ANSI SQL, and you can use Java, C# to connect to it. The licensing is input volume based, so you can use more CPU, add more nodes, and in practice for us, it has proven 200 times faster than Hive. So how we decided to load it? At that time, Vertica did not support Parquet. So from the JSON, we flattened that into CSV Hive tables, and then used Hadoop streaming jobs where the mappers will use the binary client to load data into the Vertica nodes. So this worked well as long as the team who built that was the one using it. Using it through export jobs. So export jobs are have the meaning in the context of our schedulers that there is a talk downstairs just after this one about Kettle, which is one of the job schedulers we have at Criteo. And so this implementation is done in an export job, so that user can just instantiate with some configuration so that the export are then scheduled to load data into Vertica. So as soon as other contributors external from the team started to use the export, we realized that some of them did not understood that the CSV was on HDFS was the backup for Vertica, and deleted them. And also, some of them did not realize that CSV are schemaless, and hence you don't have backward compatibility if you happen to remove or altered columns. The only stuff you can do safely that we support officially is to add colon at the end of your CSV file, which is what Hive also supports for CSV as schema evolution. And also, as the data grew, the Hive CSV table became more and more unqueryable, like it was slower and slower. So we needed a safer data format in terms of schema evolution, and a faster one. We knew Parquet, and earlier this year, Vertica allowed an Apache Parquet reader with which you can bulk load data from Parquet. You can even create external table onto HDFS files in Parquet. So the catch was that our HDFS cluster is Kerberized, and our Vertica cluster is not. We could Kerberize it, but we rely on password authentication on LDAP. And we were not so sure about Kerberizing it yet, or not in the roadmap of this project, because of the variety of users we have and their setups, also applications, because our Kerberos setup is not trivial. We have several realms with like trust in some directions. And we had the experience with Hive where lots of questions were in the support channel were about Kerberos stuff. So without, let's extend Vertica. We already had a taste of that by building an open source hyperlog implementation for Vertica. So we started a small POC with where you set up, like you put on the Vertica node the HDFS configuration, another HDFS client, and you create an external procedure, like you add also a user with a key tab, and a simple file with a HDFS command to be able to load the data locally to the Vertica cluster. So this works, like you can do that, copy the Parquet locally, and then delete the file with another external procedure. It works, but as we say, like data reliability engineering, for like this standpoint, it's not something you want to put in production. So we identified that there was no like some unforeseen difficulties with doing that, and we went with the Vertica User Defined Loader API, with which you can implement like two classes, one that will do the planning after parsing the SQL query, and the other one that does the actual data copying and parsing to put that into Vertica buffers. So in practice, you get this query, the extended UDS. The first initiator node will list, given a path, the files in HDFS, use the size of the file as estimator of the work, split the work between the nodes, and that work. And that way we can have our files in Hive being Parquet instead of CSV. So what's next? Another issue I haven't mentioned, where Parquet will help, is the schema definition. Those are done, the create tables are done in the export jobs, and all those alteration of the schemas are submitted as part of the job scheduler release process, which is unsafe and error prone. Like you only have a human that does a review and the production release to kind of catch some issues, which is not enough. So our Q1, Q2 roadmap aim to centralize all the schema definition of the hundreds of tables we have in Vertica, bootstrapping that by generating typed artifact in code from SQL, and this way we will have a single source of truth for like type safety within the code, and also automating DDL queries to alter Vertica. And what's even next? The title of the talk is about that. It's we can look at our system once we've migrated all the CSV into Parquet. There's still some migration stuff to do, but we can look at our system with having two invariants. One is that we have Parquet files and IGFS, and the other one being we want to provide SQL to analysts so that they can query the data. Everything in the middle is should support both and act as a caching layer, a more or less efficient, more or less expensive, and we can roll out several flavors of that. And it's even like a further longer-term project. Our goal is to be able to then direct SQL queries to the proper data store based on those three properties: what table there is a target and the retention of data there is a target, what the feature in the SQL does it use, because Hadoop SQL stuff. Some do not support all the SQL flavor. And a notion of cost so that we can use MapReduce or TES for the query. So now I'll pass to Håkan Jacobson, who will talk to you about what his team has been working on. It's a sister team here in Palo Alto. It's pretty exciting stuff.
So I'm Håkan Jacobson, and so this presentation was supposed to be given by two people, Raphaël and François from Storage East, which is based in Paris. Unfortunately, François got sick, so he couldn't make it to the US. So I'm from Storage West, which is based here in Palo Alto. So I'm going to talk. We also do infrastructure for analytics. So I'm going to talk a little bit about a project we're doing here in Palo Alto, which is also looking to the future of our analytic infrastructure. So the motivation for this work, it ties back to what Raphaël already said to some extent. Excuse me. We have a fair amount of data on HDFS. So our Paris cluster, one of our major clusters, has 2,000 nodes and about 160 petabytes of disk space. We ingest large amounts of data every day. So our largest table gets about 120 terabytes per day, and we keep it for like 30 days. And of course, Hive provides a SQL interface to query the data, which is extremely scalable and resilient to failures. But they get to this extreme scalability and resilience by spilling intermediate results to disk. So they write out data to disk and read it back and forth, and that sort of is very inefficient. So it turns out that most BI day-to-day queries don't really need all that scalability. So even if I can handle operations on tens of petabytes per data, most daily BI query don't really need that, maybe only a few terabytes or something like that, in which case all this machinery that Hive and MapReduce has for resiliency to failure and scalability sort of just makes the queries go very, very slow, and impedes the analysts who might want to use interactive queries. So the response times will not be good for interactive queries. So we can do better. So our first approach, like Raphaël said, was use Vertica. And Vertica is a great product. It's mature and generally excellent performance. Like Raphaël said, about 2 orders of magnitude faster than Hive, typically. And it has its own storage engine that's optimized for analytics. So our problem, though, is we don't have all our data on Vertica. So while our HDFS cluster has 160 petabytes of spinning disk, all we have for Vertica is about 1 petabyte of SSDs. So what do we do then if we want to get good query performance? Well, we move data from the HDFS cluster over to Vertica by creating a new ETL pipeline. But building new ETL pipeline is too cumbersome for ad hoc queries. So if you just want to query some data and it's not in Vertica and you want the result back fast, building an ETL pipeline is not an option really for truly ad hoc queries. So we need something faster than Hive that we can use for ad hoc queries. So what are the alternative technologies? Well, the shortcomings of Hive MapReduce has been noticed by many for quite some time. So there have been a wide variety of attempts to improve the situation. We have TES, we have Spark, Hive LLP, and so on. Facebook, which originated Hive, they also realized pretty fast that this is not very suitable for a lot of use cases for interactive queries. So they replaced, for batch processing, they replaced Hive with an in-house query engine called Presto. Cloudera has also their own query engine called Impala. It's one of the major ones, along with Presto. There's a startup called Dremio, which also has a query engine, name inspired originally by Google's Dremel. And so it comes to our little project here that's codenamed BossDB. And this is our project to find the right alternative to Hive. It should be said at this point that we're not attempting to write our own query engine. It's rather we're going to pick some technology and use it. And since we haven't decided yet which technology to pick, we just have a code name for it, BossDB, and it stands for Big Open Source Software Database. So we're going to pick one of these possible alternative partial replacements for Hive and use that to speed up interactive queries. So, to give a very crude idea about what we envision it's going to look like, it's a very crude picture, but this is sort of what we envision that the infrastructure is going to look like. So at the bottom rectangle, we have our HDFS cluster, where we can run Hive queries. At the top, we have our users who may write SQL queries directly, or they can use various query tools like Tableau and so on. In the middle layer here, we have Vertica, of course, but it requires this little ETL step in between. If we go to the right, we have BossDB, which does not require the ETL step, but can query data directly from the HDFS cluster. So the idea with BossDB is that hopefully, so the middle arrow that goes straight from Hive to the users, this is the arrow we want to sort of minimize. We want to move as much of that stuff as possible to BossDB. And can we get rid of it completely, or will there still be stuff where we have to use Hive? Probably, but we're going to do our best to move as much as possible to BossDB. The question then is, how good can BossDB be? It doesn't have its own storage engine, unlike Vertica. So if we believe that Vertica is like 2 orders of magnitude faster than going straight from Hive, maybe we could get like 1 order of magnitude through BossDB. So it's not going to be as fast as Vertica, but it's going to be better than Hive, hopefully. Another possibility is actually using it for some of the ETL stuff that goes to Vertica, because some of our ETL processing involves aggregation and stuff, and that's actually done using Hive for to generate the aggregates through SQL queries before it's sent to Vertica. So maybe there could be a little bit of a role for BossDB as a step in the ETL step to get stuff over to Vertica. Let's see. So what's the status of this project? Well, it's still very much work in progress. We haven't really gotten to the point where we can draw any conclusions yet or making the selection of technology. We haven't identified the technologies that we're interested in. We have been generating benchmark queries for them. We're also looking at other criteria for evaluation criteria for selection, like features and functionality, maturity, support, is it backed by a company or by a big open source community? Also looking at suitable hardware, what kind of nodes would you have in the cluster that would be a good fit for the architecture of BossDB. So it's still an ongoing process. What we've done so far, we've done running a bunch of stuff on Presto. We just installed Impala. We're running on a 4-node cluster. Just a few days ago, we got a 10-node cluster with less expensive hardware, so we're still installing stuff on that. So that's sort of how far we've gotten. So the benchmark, just a few words about that. Queries, we have essentially three types of queries. The queries that are based on our current workloads. So we got some from our BI analytics group who would generate a lot of ad hoc queries. We have some of the ETL queries used to populate the Vertica tables. And we got some queries generated by Tableau. We also do generating some atomic queries to test basic functionality, just like a basic hash join or a basic group by aggregation. So we can use that to sort of measure things like scalability. How well does it scale up with increase the size of the tables that we're joining or doing aggregation on? And how does it, what happens when you have memory pressure? Do you get out of memory errors? Can you spill to disk? Those kinds of things. That's sort of easy to do with if you just do basic atomic queries on basic operations. And we're also going to throw in the TPCH queries as well because it's easy and everyone should be able to handle those very, very well. Let's see, what else? Yes, so hopefully in Q1 next year, we'll be able to sort of wrap up the benchmark and make some form of selection and start rolling this out in our analytics infrastructure in Q2 or maybe Q3. So that's essentially the status of the BossDB project. So, any questions? Okay. Let's see. Yep.
Vertica on Parquet connector, why is that not an option? Just because it's open source?
No, well, Vertica is, you lose the advantage of Vertica's storage engine. I mean, it has its own storage engine that's optimized for analytic queries. And it's not clear that if you take away that advantage, that it would necessarily be a whole lot better if you go from Vertica to from Parquet on HDFS to Vertica, or from Parquet to say on HDFS to say Presto or Impala, that Vertica would be that much of an advantage, because it may be that a lot of the bottlenecks will not be the processing engine itself as much as the pipe from HDFS to our BossDB cluster. So yeah, I mean, it's would be a possibility, but also, you know, Vertica's a commercial product, so you have to pay for it. And if it's not a whole lot better than an open source product, then, you know, but theoretically, you could probably do something like that. Okay, so, and also, if you're interested in jobs, there might be some job openings at Critios, so.